Hi, hi, I'm Sirivashnita. Today I'm going to tell about pneumonia detection using CNN. What is pneumonia? Pneumonia is a infection which is caused in lungs by bacteria, fungus, or virus. It is the inflammation caused in the lungs by swelling and forming the pus in our lungs. Pneumonia can affect one or both lungs. Introduction to CNN. Imagine there is a image of bird and you want to identify whether it's real bird or some other object. The first thing you need to do is the pixels of image in the form of arrays to input layer of neural network. The hidden layers carried out feature extraction by performing different calculations and manipulations. There are multiple hidden layers like convolution layer, ReLU layer, pooling layer that perform feature extraction, and finally there will be a connected layer which is object in the image. So let us see this picture. Pic- Pixels of image fed as input, and this is input layer, hidden layer, output layer, and the figure is identified as bird. So, what is convolutional neural network? A convolutional neural network is a fed-forward neural network that is generally used to analyze visual images by processing data with a grid-like topology. It's also known as convolute. A convolutional neural network is used to detect and classify objects in an image. Below is an neural network that identify the number, real digit. In a CNN, every image is represented in the form of array of pixel values. The convolutional operations forms the basis of any convolutional neural network. And let us see the CNN model architecture. This is the CNN model architecture. These are first image is input image and future extraction, and last is classification. Layers in the convolutional neural network: input layer, convolutional layer, activation function, which is also known as ReLU function, pooling layer, fully connected layer, and flattened layer. Convolutional layer. This is the first step in the process of extracting valuable features from an image. A convolutional layer has several filters that perform the convolutional operation. Every image is considered as matrix of a pixel values. Consider the following 5 into 5 image whose pixel values are either 0 or 1. There are also a filter matrix with dimension of 3 into 3. Slide the uh, filter matrix over the image and compute dot product. Get the convolved feature matrix. ReLU layer. ReLU layer stands for rectified linear unit. Once the feature maps are extracted, the next step is to move them to ReLU layer. ReLU layer performs an element-wise operation and sets off all negative pixels to 0. It introduces non-linearity to the network, and generated output is a rectified feature map. The graph will be increasing and the original image is scanned with multiple convolutions and ReLU layers of for locating the features. Let us see the pooling layer. Pooling layer is a downsampling operation that reduces the dimensionality of the future map. The rectified future map now goes through a pooling layer to generate the future map. The pooling layer uses various filters to identify different parts of the images. So, the next step in the process is flattening. Flattening is used to convert all the resultant two-dimensional arrays from the pooled feature maps into single long continuous linear the flatten let us see the flatten matrix is fed as input to the fully connected layer to classify the image. See, this is the fully connected layer. First is input layer, and on the convolution we get the convolution layer. After the pooling layer is obtained, after the flattening is done, fully connected layer is obtained. Here is how exactly CNN recognize the bird. We have taken here the bird as an input, pixels from flattened matrix fed as input. So the pixels from the image are fed into convolution layer that performs convolution operation. This, this results in convolved map. The convolved map is applied to ReLU function to generate rectified future map. The image is processed with multiple convolution layers uh, and a ReLU layer for locating the features. Different pooling layers with various filters are used to identify specific parts of the image. The pooled feature map is flattened and fed into fully connected layer to get the final output. Let us see the activation layer. The activation layer introduces non-linearity into the network by applying an activation function to the output of the previous layer. This is the crucial for the network to learn complex patterns and flattening. Flattening is nothing but after the convolution and pooling operations, the future maps still exist in a multiple dimensional format. Flattening converts this future maps into one dimensional vector, and this process essential because it prepares the data to be passed into fully connected layers. And let us see the output layer. Output layer is nothing but in the this is the final layer from the fully connected layers is processed through a logistic function such as softmax, sigmoid, etc. Let us see the data structure used in this application. So when using CNN for pneumonia detection, the primary underlying data structure is a multi-dimensional array representing the chest X-ray, where each dimension corresponds to the image height, width, and color channels, which are then processed through convolution layers within the CNN to extract relevant features for pneumonia identification. Essentially, the CNN learns to identify the patterns with the image data to distinguish between normal and pneumonia affected lung areas. So, key points to the data structure in this application is image representation. Each pixel in the chest X-ray is stored as a numerical value in the array form, with the array dimensions representing the image height and width. Channel dimension. Channel dimension is nothing but for grayscale images. There is only one color channel, but for color images there would be red, the green, and blue RGB colors. And let us see the processing. When there are training, when we are training the CNN, images are often grouped into batches, meaning multiple images are processed together and a single multi-dimensional to improve the computational efficiency. Let us see the tech stack used. In the deep learning framework, TensorFlow, PyTorch, Keras are used. And in data manipulation libraries, we are using NumPy, Pandas, and machine utilities, Skitlearn, etc. Matplotlib also used. Data preprocessing using libraries such as Pandas, NumPy to clean, load, and prepare the image data for the CNN model. Model building. Model building is nothing but employing the chosen deep learning framework to define the CNN architecture with layers, convolutional layer, fully connected layer, pooling layer, as we discussed before. Training the model on the prepared dataset using the backward propagation, continuous algorithms, etc. So let us see the interface development. When using CNN for pneumonia detection, interfaces are typically developed around chest X-rays, allowing user to upload the image. When wait, interface development includes image upload, a simple interface to select and upload a chest X-ray from the local storage or medical database. Pre-processing module behind the screen scenes. The system might include image resizing, normalization, and other pre-processing steps to prepare the image for the CNN model. And prediction display is nothing but whether the input contains the pneumonia or not. Business logic in pneumonia detection using CNN. Image preprocessing, which includes normalization, resizing, conversion of grayscaling, etc. Development includes transfer learning, CNN architecture, uh, and so on. Training and validation, which includes loss functions, gradients, and functions to develop the CNN model, etc. Thank you.